Hello, Luke. Welcome to Lesson 65. So today we're going to be talking about two things. The first is going to be the addition of radical expressions, and then the second is weighted average. They really don't have anything in common, but that's all right. Those are the two concepts for today. So the first one, addition of radical expressions. To start, we just need to remind you about radicals. So what are radicals? Let's start simple. What are radicals? Well, the answer is, if you recall, they are simply roots. So whenever you see that word radical, think root, okay? So the root sign is this, and then we could have, the square root of 4 perhaps, which we know to be really a plus or minus 2, but in the book we're going to assume that it is, a 2, okay? So that is our radicals. Now, just as a quick reminder, how did we multiply radicals? If I have the square root of 2 and I want to multiply that by the square root of 3, can I do this? Well, the answer is yes, I can. How do I do it? And this we've learned before. Remember, all we have to do is take the numbers inside the radicals and multiply them by each other. So this would be equal to the square root of 2 times 3, which would be equal to the square root of 6. All right, so we basically just take all the numbers, combine them underneath the radical, and multiply those numbers out. Very simple, okay? And that could be 2 terms, it could be 3 terms. I could have, square root of 4 times the square root of 3 times the square root of 2, perhaps, right? And this would just be equal to the square root of 4 times 3 times 2, which is going to be equal to the square root of 24. Now, we could certainly reduce this. The square root of 4 is obviously a 2, so we could reduce this down to, 2 times the square root of 6, but we won't care too much about that right now. The point here is that when we're multiplying them, we simply put them under the radical and multiply the numbers together, okay? Now, bear in mind, just in case you ever come across this, if you have something that looks like this, maybe it's the cubed root of a 3, and you're multiplying that by the square root of a 7, all right, this you cannot multiply. All right, we can't multiply that. At least not to our knowledge right now. Later on, maybe we could talk about a way to kind of do this. But right now, there's not much that we've learned at this point to be able to do this. Although we will learn more later. All right, good. So now let's talk about adding radicals. So, if we're going to add radicals, which is the subject of our lesson today, the addition of radical expressions, let's take the square root of 3, and let's say we want to add that to the square root of 2. All right, can we combine these into a simpler form? The answer is no, we cannot. No, this just simply can't be reduced. The answer is just square root of 3 plus the square root of 2. There's nothing else that we can do here, okay? However, if I have something that looks like this, if I have the square root of, let's say the square root of 4, and I know that the square root of 4 is 2, but let's not worry about that right now. The square root of 4 plus the square root of 4, okay? What is this equal to? Well, I'm going to tell you right off the bat that this is actually equal to 2 times the square root of 4. Okay? And you might ask, well, how did you get that? And that is the meat of our lesson today. So let's talk about it. We are going to treat radicals the same way that we treat variables. All right? We're going to treat them the same way that we treat variables. So if I have something like this, if I have 2x plus 3x, can I combine these? Sure I can, right? Because they're like terms. The x's are the same. We can add the coefficients. We end up with 5x. Okay? Can I add this? If I have, 2y plus 3x, can I combine these into a simpler form? And the answer is no, I can't. That's just simply equal to 2y plus 3x. There's nothing more I can do with that because they're not like terms. So if they're like terms, piece of cake. We add the coefficients. If they're not like terms, we can't do anything with them. Same thing applies to the roots. All right, so if we kind of move over into the root world here, we have the square root of 3 plus the square root of 2. We can think of these as not being like terms. And they're not like terms because the radicands, which we call the radicands, are the numbers underneath the radical sign, these guys. The radicands, they are not the same. They're different. And therefore, we think of them as being not like terms, and there's nothing that we can do to simplify this. The solution is simply the same thing as the problem. It's already simplified. Okay? Now this one, here we have the square root of 4 plus the square root of 4. We could think of these as being like terms. Okay? Because, again, we look at the number inside the radical, or the radicand, excuse me. The radicand. We look at the radicand, which is the number inside the radical, and we recognize that they are the same. Okay? And because they're the same, we're going to treat them as if they were like terms. So imagine an imaginary 1 coefficient outside here, all right? And if we're going to treat them like we did these variables over here, we need to add the coefficients. So we add the 1 plus the 1. That's going to give us this 2. That is where this 2 came from, okay? And then we have the square root of 4. Well, the square root of 4 is the same thing as, like, you know, this x that we treated over here. Okay? So remember how to add variables, and you can easily add roots. Now, why does this work? Well, it's pretty straightforward, really, because if you have the square root of 4 and you're adding to that the square root of 4, isn't that just saying you have 2 groups with the square root of 4 in each group, which would mean 2 times the square root of 4? You know? Just like if I have 2 3s, you know, I could say that this is equal to 2 times 3, right? This is 2 square roots of 4, so I have 2 times the square root of 4, right? So that's pretty clear to see that that does indeed work. Now, if you doubt that, for this particular problem, I can actually show it in a different way too. If we have the square root of 4 plus the square root of 4, well, we know what the square root of 4 is. It's a 2. And we know what this one obviously is. It's a 2. All right, so we have 2 plus 2, which is equal to 4. And if we look at this answer that we got over here, we could simplify this to 2 times the square root of 4, which is 2, which is going to be equal to 4, right? So they are the same. So number of different ways that you can kind of see how this works out. But the bottom line is treat the roots like you would variables. Count them as like terms if the radicands are the same. If they're not the same, there's nothing that you can do. Okay? It's that simple. So let's try a couple of problems here. Let's say we've got square root of 3 plus 3 times the square root of 3 plus the square root of 2. All right, let's try to combine some of these. And to do that, again, we kind of look for like terms, like roots, you might say. And where do we see some like roots? Well, I have a square root of 3 here, and I have a square root of 3 here. So I can combine those two terms. So what are the coefficients? Well, the coefficients are 1 right here, it's invisible, and then we have this 3 that is visible right here. So we have 1 plus 3, which is going to be 4, and we just simply rewrite the square root of 3, plus the square root of 2. We cannot add the square root of 2 because it's not a like term. The radicand is different. Okay? All right, let's try another one. So if I have 4 times the square root of 7, and I'm subtracting 3 times the square root of 2, and then I'll add another 5 times the square root of 7, and maybe I'll subtract the square root of 7. All right? What would this give us? Well, why don't you pause the video, try this one by yourself, and then we'll do it together. All right, so let's see how you did. So you've got we're looking for similar roots, right? Like roots. So we have this term, which has a similar root, square root of 7. That is similar with this one, positive 5 square root of 7. And then we have also a negative, invisible 1 square root of 7. All right, so we can combine those. 4 plus 5 is 9. 9 minus 1 is 8. So we end up with 8 times the square root of 7. And then we have what's left over here, a minus 3 times the square root of 2. The square root of 2 doesn't combine with anything because it's not a like term with anything. So therefore, that is our solution. All right, very, very simple, not difficult at all. So hopefully that makes sense. Let's move on and we'll talk about weighted average. All right, so we've talked about averages before. Now we're just adding one more component to it. So maybe the easiest thing here would be to take this first problem. So Bob's test scores were 70, 80, 85, and 95. What was the average of his scores? So this first problem, this is just a warm-up problem. This is just to remind us what average is. We're not even talking about weighted average yet. Let's just look at how average shakes out. So as a review, why don't you pause the video, try to find the average of Bob's test scores, and then we'll look at it, make sure that you did it right, and then we'll move on to weighted average. Okay, so how do we find the average for Bob's test scores? Well, we simply add up all of his scores, 70 plus 80 plus 85 plus 95, and then we need to divide that by the number of test scores that there are, and there are 4. So we'll divide that by 4. So if we take 70 and 80, that's 150, and then we have an 85, and then we have a 95. If we add these up, right, we end up with, let's say, 17, 23, I think I did that right, 330. 330. Maybe I better double check my math here. 23, yeah, that looks good. Now we're going to divide that out, so we have 330 divided by 4, which is going to be, if we do a little math here, we end up with 82, so 82.5. So his final score will be 82.5. That's his average, okay, for the class or for that term or whatever it might be. Okay, so that's a straightforward problem, simple average. We just took the raw scores, added them up, and divided them by the number of scores that there were, okay? Now, let's say the teacher thought that the later tests were more important than the earlier tests. So maybe, you know, the first test was on only 10 items, and maybe the second test was on those 10 items plus another fresh new set of items. So maybe it was on 20 items. And then maybe the third test was on, you know, maybe it was 40 items maybe. And then maybe the last one was really big. It was on 50 items. You know, it's hard to say. But maybe each test was more comprehensive, had more problems, was more difficult, and therefore the teacher felt that the later tests should really contribute more to this average than the earlier tests did. Okay? And sometimes this is the way things are done. So if that's the case, the teacher might decide to add a weight to each of Bob's test scores. Okay? So the first test, she's going to give the weight, or he or she is going to give the weight of 1. Okay? The second score will have the weight of 2. The third will be the weight of 3, and the fourth will be the weight of 4. Okay, now those are arbitrary. She could have selected a 2 for the first weight and a 3 for the second, or whatever number she chose. Okay, the bottom line is that the teacher is selecting a weight for each score. And what that means, what does the weight mean? The weight means that for this first score, which was a 70, she's going to count it as just a 70. As in this case, a weight of 1, meaning she's counting it as 1 grade, 170. Okay? And now for Bob's second score, she's going to count that test as being 2 tests. It has a weight of 2, okay? Which is basically the same thing as saying that test counts as 2 tests. So instead of just adding 80, we're going to add 80 twice, okay? And then the third test, well, the third test is 85, but now the teacher wants to give that a weight of 3, which means that it's equivalent to 3 tests at 85. So we need to add 85 3 times. Okay? And then finally, the fourth test has a weight of 4, so the 95 would have to be added 4 times. So 95 plus 95 and 95 and 95. Okay, so hopefully you can kind of see how this is working. We have 70 is only in here once. That was his first test. 80, which was his second test, contributes 2 numbers to the problem. The third test contributes 3 numbers, and the fourth test contributes 4 numbers. So the test that's the most influential on this final average is going to be the fourth test because it's responsible for 4 of the numbers, 4 of the grades, okay, which is more than any of the other tests were. Okay, so hopefully that kind of makes sense. That's what weighting means. It means we duplicate certain tests or certain numbers so that they contribute more to the average. Okay, so now how do we find the average of this? Well, it's slightly different. I mean, obviously we still need to add up all these numbers. Okay, a lot of adding there. But what do we divide it by? Up here we divided it by 4 because that was the grand total number of tests. Well, here there still are only 4 tests, but because of the weighting system, we actually have a lot more than 4 grades in the numerator. So we actually have to divide it by all the grades that are in the numerator. So in this case, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 total grades up in the numerator, which notice that's a lot more than these 4 tests that he took. But because of the weighting system, we end up with 10 grades. So we need to divide it by 10, not 4 this time. All right, so let's just go ahead and compute this. We'll add all these up, and I'll do that quickly. So it would be 865 divided by 10, and that we just need to move the decimal over, so we end up with 86.5. So his final average is an 86.5. And you can see that in this case, it's very different from the average that we took earlier. The first average was 82.5. Now it's 86.5. So it went up 4 points. Okay? And the reason it went up 4 points is because we said that this grade, the 95 grade, was more important than all the others, and therefore should contribute to more of the final grade. And because he did better on that test, it actually helped his score. Now, if he would have done worse on this test, then it would have, made his score worse. However, that's not the case here. Because he did so well on the fourth test, and really because he did better on the third test and the second test, both of which were more important than the first test, all of that made this grade better than what it was with just the raw average. Okay? So Bob should be very happy that his teacher is using a weighted averaging system for his grade. Okay? So let's try a couple of these problems and make sure that you have the hang of this. All right, so Jim's scores were 60, 70, 80, and 90. What is the weighted average of his scores if the tests were weighted 1, 2, 4, 6 in that order? So 60 was weighted as a 1, 70 was weighted as a 2, 80 as a 4, 90 as a 6. All right, the fastest way to do this is simply to, think of average. How do we average? Do the same thing you normally do, only now apply for each grade or each item that you're averaging the weight. So 60, and just to be clear, I'll say 60 is worth the 1, even though I know 60 times 1 is just 60. But that first grade is worth a weight of 1. So we're going to take the 60, multiply it by its weight, which is 1. Then we're going to add the next grade, which will be 70. Now I could say plus 70 because the weight is 2, so it needs 2 70s. Or I can just say it's 70 times 2, right? Just a faster way of adding. And then I could say plus 80. And what's the weight of 80? Well, the weight of 80 is a 4. And again, instead of writing 4 80s in a row here, we're just going to say 80 times 4 because that's its weight. All right? And then we have plus 90. And the weight of 90 in this case is 6. So it's going to be 90 times 6. All right? And then we have that all being divided by what? See if you can tell me. What's going to be in the denominator here? Well, hopefully you said that it would be a 13. All right? And how did we get this 13? Well, because this last grade accounted for 6 grades, you might say. It has a weight of 6. So there are 6 grades in there. There are 4 grades in this one, 2 grades in this one, and 1 grade in this one. So if we add up all of the weights, that's going to tell us what the kind of the total number of grades are. So in this case, we have 6 plus 4 is 10, plus 2 is 12, plus 1 is 13. All right, so that's where that number came from. All right, now all that's left is to kind of crunch the numbers here and see what they give us. So if we just kind of multiply things out, this is going to equal 60 plus 140 plus 320 plus 540 all over 13. All right, and if we just simply, well, you know what, here, I'll save some time here. I'll just pull the answer up. Okay, so everything combined is going to be 1060 over 13. And again, just to save a little time, let me pull up a calculator here. Just divide that by 13. And we end up with 81.54, let's say. 81.54. Okay, so Jim's final grade, his final average, will be 81.54. Okay, excellent. All right, and actually, just if you're curious, if you would have just taken the straight average from here, the average would have been right in the middle. It would have been 75. So because of this, 90, this last test, having a weight of 6, which is pretty incredible, it brought that 75 all the way up to 81.54. Okay? Excellent. Let's try another one. So, in the graduate level course Smith was taking, each of the 3 tests were weighted 20%, and the final paper was weighted 40%. Smith's scores on the 3 tests were 60, 70, and 80. His score on the final paper was 60. What was Smith's overall score for the course? So this has a lot of percentages in there, okay? And it may be a little bit confusing because of all the percentages. So probably the best step here is to first organize it and realize that, okay, we've got several things going on here. We have scores, right? We've got test scores. Then we've also got weights, right? What are the weights for these test scores? So if we look at the problem, let's kind of just categorize things here, organize the information that they gave us. So each of the 3 tests were weighted 20. So how many tests were there? Looks like there were 3. Oh, there were 3 tests and there was a final paper. Okay, so we have, test 1, test 2, test 3, and then we'll go final F for the final paper. Okay, all right. So there we have kind of our layout, our different scores. Now, each of the 3 tests were weighted 20%. So the weights of test 1, 2, and 3 were 20% each. So this one has a weight of 20%. This test 2 has a weight of 20%. Test 3 also has a weight of 20%. Okay? And then the final paper was weighted 40%. So the final paper, we have a 40% weight. All right? And by the way, if these were all the tests, if they're telling us that these are all the tests, these percentages better add up to 100 because, this would be 100% of all the tests. 100% meaning everything. So we have 20 and 20 is 40 plus 20 is 60 plus another 40. They do add up to 100%. So these are all of the things that will go into giving Smith his grade. Okay. All right. Now, Smith's score on the 3 tests were 60%. So here now, his score was 60%. Okay, so his score was 60% for test 1. Test 2 it was 70%. And then test 3 was 80%. And then his score on the final paper was 60%. Okay, so he didn't do very well on his final paper, just kind of looking at the numbers here. His final paper, which accounts for 40% of his grade. So it has the strongest influence on his grade. He got a 60%, which is an F. So he did not do well on his final. All right. He didn't actually do well overall when you look at a lot of these scores. You got an F, you got a, what is that, another F, and then a C. So anyway, not doing too well here, but let's see how it shakes out. Okay, so how do we find the weighted average? How do we find his overall grade? Well, to do that, we're going to do the same thing we've done before, only now there's one additional step. We want to, translate these percentages into decimals so that we can actually kind of work with them as numbers. So the first score, instead of 60%, we're going to change it into a decimal, and it's going to be 0.6. Okay? We're going to multiply that by its weight, and its weight is 0.2, written as a decimal. All right? His second score was 70%, which is a 0.7, and its weight is also a 0.2. The third score was 80%, so that's a 0.8 multiplied by 0.2 as well. And then the final paper, he got a 60%, which would be a 0.6 multiplied by the 0.4 weight. And now we have to divide that. Now, what are we going to divide this by? All right. This one is a good example because it's a little confusing. There were kind of 4 tests, right? So you might think, oh, I should divide it by 4. But then you think, well, but they're weighted. So each one is weighted a little differently. So it shouldn't be by 4. It's got to be something more than 4 or less than 4. It's hard to say. Well, remember the process that we used on the last problem. Remember here, all I told you was that for this lower number, the denominator, you need to add up all the weights. Okay, that'll give you the lower denominator, 6 plus 4 plus 2 plus 1. So the same thing applies here. We're going to add up the weights. So the weights are 0.2 plus 0.2, which would be 0.4, plus 0.2, which would be 0.6, plus 0.4, and 0.6 plus 0.4 is equal to 1. Right? So we end up with a 1 underneath. Isn't that wonderful? Okay, so now we just need to multiply these out. So what is 0.6 times 0.2? Well, that's 0.12 plus 0.7 times 0.2 is going to be 0.14 plus 0.8 times 0.2 is 0.16. And then plus 0.24. Okay, let's add all those up. We have 0.12, and maybe it's easier to do it this way, 0.12, 0.14, 0.16, 0.24. If we add these up, you get 16.66. So we end up with 0.66. Now, to get that into a score that's similar to these other scores, let's turn that back into a percent. So 66 as a percent would be 66%, right? So his final grade is going to be 66%, which is the equivalent for most classes. That's equivalent to an F. So he did not do very well, okay? But hopefully that makes sense to you. So real quick, the steps for weighted average. Organize your material, organize it into, what you're trying to average and the weights for those things. And then you're going to add up, you're going to sum the weights times the scores. The weights times the scores, or the scores times the weights, I should say. That's the way we have it written here. Scores times the weights. Okay? And then you divide that by the sum of the weights. Okay? So maybe even in your notebook, this would be a good bit of advice to put in there. Let's put in the steps. So first, you might say, organize information into, I'm going to just say scores. It might not always be scores. It could be anything, but we'll just use that as an example. Information into scores and their respective weights. Sorry about the noise in the background here. Weights. And then secondly, we are going to sum the scores times their weights. And then finally, add the weights to get the denominator and then lastly, divide. Okay? So those would be the 4 steps. So maybe write those down in your notebook and maybe, title it, weighted averages so that you can refer back to this when you hit an average problem as kind of your cheat sheet, okay? So that you can step your way through the problem. But once you've done a couple of these, I think you'll find that they are pretty easy. It's just a matter of learning the process and getting that down. Excellent. Well, I think we will stop here for today. Work on these, and we will continue tomorrow.